Alright guys, we will continue into part 2. Alright, so there are a lot of op-amp circuits. Okay, so here I will show you 4 basic of op-amps. Okay, so as I previously mentioned that the op-amp can be used either we want to do the circuits on addition, subtraction or differentiate. So it depends on the function will depends on our circuits. Okay, so kat sini ada 4 circuit or configuration yang saya nak tunjuk. First is inverting op-amp. Okay, second is non-inverting op-amp, and third is differential op-amp, and fourth is summing op-amp. Okay, so basically the inverting op-amp adalah kita nak invert which is our input to our output. So we want to, maybe the input is in term of positive sign, and then we want to convert it into negative sign. Alright, so that's the inverting. Okay, so and then differential op-amp, maybe we want to differentiate our data, so we use these circuits, and then if this is a summing op-amp, which is we want to sum of the input. Maybe we have 3 input that we want to sum it into 1. Okay, we can use this setup of circuits. Okay, so for your assignment for this week, okay, I want you to list down the op-amp circuit, which is you can use this one, inverting, non-inverting, the differential op-amp and summing op-amp. Okay, so I want you to explain to me what is inverting op-amp in more details, or you choose which circuit that you want to explain. Okay, maybe you want to talk about the summing op-amp. Okay, so you talk about that, the summing op-amp. Alright, so and then you record your your video, okay, like your lecture like me. Okay, so you explain about that one, either the op-amp circuit. Okay, you can choose either one. Okay, so and then submit to me the video. Alright, so that's your assignment for this week. Okay, so I will not explain this one. Okay, so if you want to know more about this one, you can see your friends will explain about that one. Alright, so I want to explain how you want to troubleshoot the op-amp circuit. Alright, so for example, here we have inverting op-amp. Alright, so inverting op-amp, which is alright, so for example, in this circuit, we have our input here is negative 0.2 volt. Alright, and then we have we have the resistor here 20k. Okay, so we need to measure the output voltage. Okay, so since the RF over Rin, we divide that, so 20k divided by 1k, we get the value, the factor is 20, right? So the expected output voltage, it should be 0.2 times 20, so it should be 4 volts. Alright, so we do the measurement, and then we noted that the output voltage is 0 volts. So that means that the circuit is not functioning correct as expected, as we expect. Alright, so what should we do? Okay, so first we need to measure and record voltage at both negative and positive non-inverting pins. Okay, so our measure, it should be not more than 10 millivolt, 10 millivolt from the input and inverting and non-inverting pins. Okay, if the voltage level is not within this value, check the external circuit and components. Alright, Next is the measure the voltage on the positive and negative power supply terminal on the terminal of the op-amp amplifier. Okay, so the measurement should not be just measured on the PCB but also directly on the op-amp package. Okay, so in case the supply is present on the printed circuit board but not on the IC pin, look for the following troubles. Okay, so we track on the printed circuit board. Okay, either they have a discontinuity ataupun defective. Okay, so feed through hole on the PC board is not metallized the entire distance through the board. Okay, so if device tu berada di dalam socket, the socket it must be defective. Okay, so if the voltage is not present on the printed circuit board, okay, so we should start tracing the power supply voltage on the board to determine the cause of its not being present. Okay, so but if the power supply on the op-amp is correct, okay, so it must be possible that the output circuit is excessively loaded. It may be recalled that it was stated that the op-amp can be delivered only 1 to 10 milliampere to load connected at its output. Okay, so to rule out this possibility, so isolate which pin from connection on the PC board and observe the following possibility. So we isolate just the feedback circuit and measure the voltage at the output pin. So here is our feedback circuit. Alright, so we measure the voltage the output pin. Okay, so the voltage should be positive or negative voltage because the output voltage is still zero when it is isolated from the feedback path. The op-amp is defective. Okay, so but if the output voltage is positive or negative, okay, the device may still be defective. In that case, we should determine the op-amp output if is capable of going positive or negative voltage level. Okay, as the output may be stuck at one voltage level in case the device is defective. Alright, so that's the how we want to measure how we want to fault diagnosis or how we want to troubleshoot in op-amp circuits. Alright, so that's all for this chapter 9. Okay, we will continue into chapter 10 on another video. Alright, thank you.